Hi there. In this video I'll be answering a question on NPN transistors, looking at the operation of a circuit which automatically switches on an LED when light level decreases, and explaining its operation. Here's a question from the 2007 standard grade credit paper. A high intensity LED is used as a garden light. The light turns on automatically when it becomes dark. The light also contains a solar cell which charges a rechargeable battery during daylight hours. Part of the circuit is shown below. And here it is. We're then asked to state the energy transformation in a solar cell. The answer is, of course, light to electrical energy. Part 2 says, at a particular light level, the voltage generated by the solar cell is 1.5 volts. Calculate the voltage across the rechargeable battery at this light level. So, once I make more space, I'll show two ways to work out the answer. Hopefully you've spotted that the two resistors make up what's called a voltage divider. The resistors are in series, so the 1.5 volts generated by the solar cell will be split. You can also see that the rechargeable battery is in parallel with the 2400 ohm resistor. So to work out the voltage across the rechargeable battery, we're just calculating the voltage across the 2400 ohm resistor, which makes up part of the voltage divider. If you're not too confident with voltage divider circuits, then look out for this video, which goes into a little bit more detail. Understanding voltage dividers is very important if you're going to get your head around transistor switching circuits, like the one we'll see later in this question. Getting back to the circuit then, let's call the top resistor in the voltage divider, the 600 ohm resistor, R1. We'll call the 2400 ohm resistor R2. We can calculate the voltage across R2 using this equation. Here, V2 is the voltage across resistor R2, that's what we're trying to find, and Vs is the supply voltage, that's the 1.5 volts generated by the solar cell. Substituting our values into this equation, we get 2400 divided by 3000 times 1.5, giving us an answer of 1.2 volts. This dotted line is going to separate the two methods of calculating the answer so that we can compare them later. This second method is useful if you're asked to calculate the current in one of the resistors. We don't have to do that here, but it could be something that comes up, so make sure you remember how it's done. The first step is to calculate the total resistance of the two resistors in series using this equation. So we're basically just adding the two values together. That gives us 600 plus 2400, which is 3000 ohms. Next, we calculate the current in this part of the circuit. That'll give us the current in the 2400 ohm resistor, R2. To do that, we use Ohm's law. The supply voltage Vs is equal to the current I times the total resistance RT. We can then divide both sides by RT to make current I the subject of the equation. Substituting our values of Vs and RT gives us 1.5 divided by 3000, which is 0.0005 amps, or 5 times 10 to the power of negative 4 amps. Since the resistors are in series, and current in series is the same at all points, the current in the 600 ohm resistor will be the same as the current in the 2400 ohm resistor, 5 times 10 to the negative 4 amps. Finally, to get the voltage across R2, the 2400 ohm resistor, we use this equation, and multiply the current I times R2. This gives us 5 times 10 to the negative 4 times 2400, which unsurprisingly works out to be 1.2 volts again. I'd recommend that you know both methods, but especially the second, since it allows you to work out the current in case that's required. Here's part B of the question. The LED is switched on using the following circuit. We're then asked to name component X. Now, there's a clue in the title of this video because component X is an NPN transistor. We would also be allowed to just write transistor here. The next part of the question says, the graph below shows the voltage across the LDR in this circuit for different light levels. Light level is measured in lux. Well, it would certainly help if we could actually see the graph. Here we go. We're told in part 2 of the question, for the LED to be lit, the voltage across the LDR must be at least 0.7 volts. What's the maximum light level for the LED to be lit? All we have to do here is draw a line upwards from 0.7 volts on the x-axis until it hits the line, then horizontally along to the y-axis. So you can see the voltage across the LDR is 0.7 volts when the light level is 20 lux. You might see from the graph that if the light level increased above 20 lux, then the voltage across the LDR would decrease and the LED wouldn't light. This is why we're being asked for the maximum light level for the LED to be lit. Now, this is the final part of the question. B part 3 asks us to explain the purpose of resistor R. If you're anything like me, then you'll have forgotten all about resistor R by this point. So let's look at the circuit again. Looking at this part of the circuit, you can see that resistor R is in series with a light emitting diode, or LED. Anytime you see this, it's there for one reason, and that's to limit the current in the LED, protecting it from damage. That's a good phrase to memorise in case it ever comes up. Now, that's the end of this question, but I'd just like to talk a little bit more about how this circuit operates. First off, this, remember, is an NPN transistor. It acts as a voltage operated switch. And this part of the circuit is a voltage divider. The voltage across the bottom component, the light dependent resistor in this case, is very important because it's also the voltage between the base and the emitter of the NPN transistor. If this voltage increases above a certain value, then the NPN transistor conducts. When the transistor conducts, a current flows in it, and in this circuit, with the transistor conducting, there would be a current in the light emitting diode, which would now light. So we need to get the voltage across the light dependent resistor, or LDR, to increase above a certain value for the NPN transistor to conduct. And for this to happen, the resistance of the light dependent resistor would have to increase. Now, you should hopefully know that the resistance of an LDR decreases as light level increases. In other words, when it gets brighter. So, if we want its resistance to increase, then we'd have to decrease light level, make it darker. So here's how the circuit operates. As light level decreases, the resistance of the LDR increases, and the voltage across the LDR increases. It's really important that we mention the resistance of the LDR and the voltage across the LDR here, and don't just say the resistance and the voltage. So, when this voltage rises above a certain value, the NPN transistor conducts. And finally, the LED then lights. And that's us. As I said before, the NPN transistor acts like a voltage operated switch, just like a MOSFET. If you're still not understanding how these circuits work, then take a look at this video from the Mr. Smith catalogue of YouTube videos. For more information on upcoming videos, summary sheets and so on, visit physics-podcast.co.uk. Thank you for listening.